So far in your math careers, you've always talked about measuring angles in degrees. It's always what we've done in geometry class. We might talk about there being 180 degrees in a triangle, or talking about turning a full circle is 360 degrees. And really, it's gotten us far. We're just fine with that, having that measurements. But sometimes it's convenient to use a different form of measurements to say how big an angle is going to be. As you get on to more advanced math classes, you will use this new type of angle measurements more than you use degrees. You'll start to leave degrees behind as you progress for different reasons that you'll get into later on. But I want to kind of start things out here by recalling what we talked about with the standard position of an angle. We have our side that's fixed along the positive x-axis, and this side right here is going to move like this. Typically, it goes counterclockwise. Sometimes you can go in the other direction. But if you fix the radius, it's not hard. Like you can picture, I even put it in there. If I kept going in a circle like this, we're going to basically be tracing out a circle. You can see right there, as I move my second part of my terminal side of my angle around, it traces out a circle. That's going to be kind of a key thing in figuring out what's going on here. So let me actually delete these so I can draw one, and I'll show you what I mean by that. So, on this problem right here, let's say I had an angle like, there's going to be my initial side, and I'm going to go ahead and sketch my circle again. Say I had a circle something like this. And I was basically looking at taking my radius right here. The radius on the circle we can think of as that yellow piece. And I wanted to say, okay, I'm going to take that yellow radius, and what I'm going to do is start right here, I'll draw this in red, and wrap my radius around the outside of my circle. So we're going to say that yellow line and that red line are the exact same length if you were to straighten them both out. We took our yellow radius and we laid it out along the edge of the circle right there. The piece of the circle, which is called arc length. You might have seen it a little bit in geometry. We don't have time to do it for this year, but you'll definitely see it again in pre-calc. The length of this piece right here, we're saying if this is radius r, so this piece is going to have length of r as well. The arc length of that piece is r. So whatever angle it has to be inside our circle right here, usually we'll use the letter theta to represent an angle. Theta right there, to make it so the yellow piece at the bottom, the radius, is the same as the red piece, has a unit of 1 radian. So we talked about measuring angles in degrees before. We're going to talk about measuring angles in radians right here. And a radian is basically, 1 radian, that unit, is equivalent to, okay, how big does my angle need to be so the red guy on the outside is the same side as the yellow guy? So when you talk about radians, this new unit of measurement, you can kind of see in here, the word radius is inside of the word radian. You can kind of see the similarities there. When you're talking about a radian, I want you guys to think about wrapping the radius around a circle. So this is going to be a unit that will focus on doing just that. So we're looking at how the angle compares to how many times we can wrap it around the circle. I'm going to go ahead and erase this picture right here and show you one more example before I move on to the next slide. So, let's say we had another circle, and we're kind of following our angle along on the outside of our circle. It's not a perfect circle, but bear with me on it. We have our initial side. And in this problem, let's say we actually know the radius. Let's say my radius was 5. And now what I'm going to do is I'm going to look, and I'm going to start wrapping my radius around the circle. Picture if I took this piece right here. Maybe that piece also has a arc length of 5. So if this piece right there is 5, that means whatever angle it takes to get from here to here is 1 radian. Because the red piece on the outside is the same as my radius. Now let's say I kept going, and I did that again. I'm maybe over here somewhere. If this is another 5, then the angle that it would take me to get to right there I'll make that one a yellow angle. If I go all the way from here to here, that fit my radius twice. I was able to put 2 radii together. That's going to be 2 radians. If I were to do it a third time, I would call it 3 radians. If I only got like 12 or something like that, I'll actually show that. Say I want like an extra 2. Well, I was able to put my radius 2 full times, and then a portion of that, so I would be dealing with a decimal of radius. Specifically, it looks like it would be, if I went to right there, we'd be looking at 2.4 radians if you were to go all the way to there. So that's the basic idea of how a radian works, and they're really not as bad as they initially seem. I want to show you what's going on through a major question related to this. So we're kind of wrapping the radius around the circle, and I want to know how many times could you do that in a random circle? If I just give you a random circle in the coordinate plane, and I don't know the radius, we're going to say it's a radius r, so it's just a random variable. The question becomes, how many times can I wrap that r around the circle? And if you know your geometry, you should be able to come up with an answer for this. Maybe if you want to, you can pause the video and see if you can answer that question for yourself. But how many times can I fit this red guy around the whole outside of the circle? And I'll answer that in just a second. So, if you recall from geometry, we learned about something called the circumference. And circumference really is the distance around the circle. So what we want to know basically, if we can find our circumference, we can divide it by r, and we can get our answer. Now, this formula for circumference, there's 2 of them, but the one that you probably use, circumference equals 2 pi r. R is your radius. Well, if my radius is r, I want to know how many times I can fit this, like the radius around this, because that's our entire length all the way around. Well, 2 pi r divided by r is going to be 2 pi. So you can fit that radius 2 pi times around the circle. That's like 6 point something. So a little over 6 times that you can fit it around the circle. So this is actually a really important note that will be relevant when we're converting between degrees and radians. First of all, once around the circle is 2 pi radians. So if I wanted to know, if I just wanted to do an angle that went all the way around the circle, that would be 2 pi radians, because you can see right there with my circumference formula that follows pretty quickly. Now, if you remember from degrees, once around the circle is 360 degrees. Well, it's 2 pi radians, too. So what we can also say is that 2 pi radians is the same thing, or it equals 360 degrees. So 2 pi radians is the same thing as 360 degrees. Those two are equivalent. They say the same thing. Now, keeping that in mind, to wrap up this video, I would like to talk about some good radians to know. Just like you know 90 degrees is a right angle, like that would be a 90-degree angle, you need to know by looking at it what radians are very common. So, good radians to know. And I'm going to go ahead and sketch a circle again. Makes it easier to see what's going on. We've got our coordinate plane, got a circle right here. First of all, when you make these angles, you start at the same spot as before. You still have your initial side of your angle going right along there. And that is either 0, if you just 0 radians, if you don't go anywhere, just like with degrees, or if you go one entire time around the circle, it's also 2 pi radians. Well, if you think about it, an entire trip around the circle is 2 pi radians. That means if I only went halfway, so I only went from here to here, logically that's half the distance, that's going to be pi radians. So if you had a 180-degree angle, one that went like this, so it was just like a straight angle, instead of 180 degrees, you can also say it's the same thing as pi radians. Well, if pi is the halfway point, let's say I want half of that. I went to right there. That's got to be half of pi, or pi over 2 radians. So pi over 2 is the same thing as 90 degrees. Pi over 2 radians, 90 degrees. And doing similar logic, if I were to go down to here, I'd be adding together a pi and a pi over 2. This guy down at the bottom is 3 pi over 2. And you can apply a similar argument. If pi over 2 is right here, that means half the way there, or in other words, a 45-degree angle, is the same thing as pi over 4 radians. So like this angle right here would be pi over 4 radians, or 45 degrees. And I'm just going to fill in a couple more using the same logic. So let me get rid of this. Put that back over here. Pi over 4. If you were to go right here and make it even on both sides, that would be 3 pi over 4. Down here we got 5 pi over 4. And finally over here, we have 7 pi over 4. So these are some common radians. Again, it's just another way of measuring an angle.